we describe our approach for utilizing virtual reality devices to do earthquake safety training. Earthquake safety is a major issue in many parts of the world. Due to the frequent occurrence of earthquakes, increasing losses are caused. Under such circumstance, a more effective safety training method is necessary. For this reason, we introduce VR devices into this safety education area, and in our work, we prove the effectiveness of the VR training. By searching through the Sun database, we find some of the typical objects in specific types of rooms. Then we place furniture and objects commonly available in the rooms of the corresponding scene types. In our work, we divide the objects into 3 categories: structures, furniture, and props. We assign materials to all the objects, which we use to calculate their mass and to assign their coefficients of friction. This allows for physical simulation in the Unity 3D engine. Our human model consists of several capsule and box colliders. Each body part is assigned a durability value. For example, if something hits one's head, more damage might be caused than if one's legs were hit, so the durability of the head should be smaller. We use the track positions and orientations of the head and the 2 hands as constraints, which correspond to the head and 2 hands of the virtual human. The inverse kinematics algorithm is applied to deduce the positions of all the other joints of the virtual human in real time. Thus, the pose of the virtual human is updated in real time to mimic that of the user. We update the velocity of the floor in Unity 3D engine along the X, Y, and Z axes every frame according to real history actual data downloaded from Peer Ground Motion database. As the room structure begins to move, objects in the room shake as well, causing some of them to fall down or even break into pieces. We create several scenes of 3 common room types: dining rooms, living rooms, and offices for training. People who undergo the training will experience the virtual earthquake in these rooms, thus they can learn important survival skills during the process. Here we show a training process. We compared the VR safety training results with the results of 2 traditional methods: video training and manual training. We also make comparison with non-training condition. Participants in the 4 training conditions are put into 3 same VR scenes, which are different from the ones for VR training scenes for testing. The results show that participants who undergo the VR safety training generally perform better than people who undergo the other training methods. We record the positions of the human body and all objects, together with what objects the participants are looking at detected by a ray casting method, in each frame. A point cloud is applied to reproduce the testing process. We consider an object to be dangerous if it would fall within 0.5 meters of the participants within the next 2 seconds, and use it as a percentage K, defined as the number of dangerous objects that are noticed by participants, divided by the total number of dangerous objects. The results also show that VR training participants pay more attention on the dangerous objects. Thanks for watching!